Hello, good morning, or good afternoon, or good evening, whenever you're watching this. Today we're doing set builder notation, interval notation, and graphing. These are together because these are just three different ways to describe a set. So first let's look at the ways we already know how to describe a set. So we can already describe a set just using language, just regular English sentences. And then the first way we described a set earlier was just by roster form, which just means listing. And basically those are the only two, English and roster form, that we've done so far. So we're just adding to this list set builder notation, interval notation, and graphing. But the interesting thing about these new ways of describing sets is that you can't use all of these notations to describe every single set in the world. These notations have limitations. And actually roster form has a limitation also, but I don't think we have an example of that. So set builder you can use to describe any set that has naturals, wholes, integers, rationals, irrationals, or reals. So you can describe any real number, since these are all the real numbers. You can describe any real number using set builder notation. Now interval notation is different. You can use it to describe some of these sets, but not all. So I'll just put some here for now, and then you'll see why in a minute, why you can't use it for certain sets. And graphing also has limitations. So it depends, these two, it depends what the set is, if you can use those or not. Okay, so let's do an example first of set builder. So first I'm just going to make a random set using roster form. So I have a set here of integers from -2 to 3, so there are 6 elements in the set. Cardinality is 6. And this is how I would write the same set in set builder notation. X I'm just using as a variable. Okay, now that probably looks like a bunch of gobbledygook to you right now. Or I've heard some people say it looks like Martian. But it's actually quite simple. So X is just a variable I'm using. You could use Y, Z, any variable you want. I'm using this variable to represent every element in the set. That's what X stands for. And then this bar is just a dividing line between me telling you what variable I'm using and the description of that variable. So this line just stands for the phrase such that. This set, let's give the set a name, we'll call it A. Set A has all x's such that x is blah blah blah. Okay, now let's see what the blah 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 is. X is an integer. Okay, so we've narrowed it down. Every element in this set is an integer. Plus, or that caret literally means and now what I'm going to tell you is a little more specific than just saying it's an integer. and x is between -2 and 3, including -2 and 3, because I have the less than or equal to here. So it's including -2 and 3. So this part is the description of every element x in the set. And you can see by looking at the roster form that it is an accurate description of those 6 elements. Okay, that's set builder. Now there are a couple variations. It's not so strict that you have to write it like this. This part of the description, you could say this. You could say -3 is less than x, which is less than 4. That doesn't change anything about what the 6 elements are, because now I'm saying x is greater than -3, and remember it's an integer, so that means the lowest value x could be is -2. And it's less than 4, so the highest value that x could be is 3, because we're limited to integers. Now, you can also graph this same exact set. So I just draw a number line. I'm just labeling the values that I need. Of course, there are more in both directions. And then to show that my set includes -2, I just put a filled-in circle above the -2. And I also include -1, 0, 1, 2, 3. Okay, so that's the same set as that, which is the same set as that. Roster, set builder, graphing. Okay, let's try another example. Okay, this time I'm going to not list it. I'm going to use English. All naturals greater than 3. Okay, so in set builder, I'm going to use x again. I'll call this set B. So set B is all x's such that x is natural. We always nail down what type of number it is, what type of number family it belongs to. And x is greater than 3. This one's pretty easy to do because it's basically from left to right, literally what the English says. All naturals, x is greater than 3. Now, are there variations here? Yes, I could say x is greater than or equal to 4. And I wouldn't be changing the set at all by saying that. But saying x is greater than 3 is a little easier. Okay, now the graph. 1, 2, 3, 4, 5. So I know I need 4. And I know I need 5, because that's greater than 4. And I know I need every natural number greater than that. So how in the heck do I graph that? If I were listing, I could go 4, 5, 6, 7, ... This is perfectly legal because since there is a pattern here, each successive element is just one greater than the first one, I could put ... and everybody understands what the rest of the elements are going to be. However, when we graph on a number line and it's an infinite set in the positive or negative direction, we do not go like this on a number line. It's just not done. I think if I did that, you would understand what's going on, but we just don't do that. So this kind of set that's infinite in the positive direction can't be graphed. Okay. That one cannot be graphed. You can list like that in this case, but can't be graphed. Okay, here's another example. All rationals. Remember, that's all fractions between 1 and 2. Okay, so for example, this would be 1.5, 1 3/4, 1.1, 1.2, 1.3, 1.4, all those. Not including 1 and 2 because I say between, not including. First of all, the set builder. X, such that X is rational and between 1 and 2. So 1 is less than X, which is less than 2. Now, can I list these? Well, we know that rationals are listable if you want to list all of them. But if you just want to list the ones between 1 and 2, are they listable? Well, I know that 3/2 is in there. I know that 5/4 is in there. But how do I list that? Is there a smallest rational between 1 and 2? Well, I can think of a rational that's really close to 1. Closer than that, and closer than that. How about if I start with 100/99? That's really close to 1. Well, I could think of one that's even closer to 1. 1000/999. That's even closer. But I can keep doing this. I can keep picking numbers that are closer and closer to 1, and I will never find the closest number to 1, the closest rational number. So there's no starting point near 1. And there's no starting point, there's no highest number close to 2, because I can keep picking numbers closer and closer and closer to 2. If I show you the graph, it's pretty clear. So if I pick this number, well, you could just come back and pick a number that's closer, right? And then I could pick a number closer. And then you could pick a number even closer. So there's no smallest number in this list. And there's no highest number, because I could keep doing the same thing. So this set of numbers is not listable. Not listable. And you can also not graph it, as you can see, because there are an infinite number of rational numbers between 1 and 2, and it's impossible for me to list them or graph them using dots, right? I can't use the dots because between any two dots, I could find another dot. And we call that density. When there's too many values for you to list in there, that's the concept is called density. Those numbers are really, really dense. But we do have set builder, and we do have English for this set. Okay, we're going to do interval notation now. And I think you're going to feel like the chains have been taken off your hands, because interval notation is quite a freeing experience. It's a breath of fresh air. Interval notation can only be used for real numbers. And by that I mean you can only use it if the set includes all types of real numbers. between any two endpoints. If you're only talking about naturals, if you're only talking about wholes, only integers, or only irrationals, or only irrationals, you can't use interval notation to describe any of these sets. But if you're describing reals, which includes all of these, then yes, you can use interval notation. Okay, so this is what I mean. Here's a set between all reals between 0 and 1. Okay, so 0 point whatever up to 1, all those real numbers. Set builder, you can definitely do it. That's what it looks like in set builder. Can you list it? No, you cannot list. So no roster form. We tried that a couple of lectures ago, listing the reals between 0 and 1, and we proved that it's uncountable, right? But we have this other way of describing this set of reals that we haven't used before for naturals or wholes or integers. It's called interval notation. So this is what it is. For this set, all reals between 0 and 1, the interval notation is simply that. A set of parentheses with a 0, 1 inside. Now, why does that work? Why does that mean that? Well, the parentheses simply mean that, and I'll use a graph to explain this. The parentheses simply mean that the 0 and the 1 are the bookends. Your set is limited by the gap between 0 and 1. So that's what that means. And then since we are talking about reals, that includes every type of number in this gap. It includes naturals, wholes, integers, rationals, and even irrationals. So it's perfectly fine to have this very simplified notation for this, because it's understood, since we're talking about reals, and this is only used for reals, that we are including everything between 0 and 1. That makes the graph easy to do also. Since we're including every value between 0 and 1, then all we have to do is draw a line from open circle to say, I'm including every single number between 0 and 1, natural, whole, integer, rational, or irrational, all reals. And since everybody understands this kind of graph and this kind of notation is only used for reals, then there is no debate about what this means. Now, what if I'm including 0 and 1? Okay, so that's why we have this. Instead of parentheses, we have square brackets. What does that mean? It means that I have the same interval, the same gap, but this time I'm including 0 and 1 in my set. It would be the same thing as this. If you were doing set builder notation, this would be in your braces. Can you mix it up? Can you have something like this? Yeah. This means I want to include the 0, but I don't want to include the 1. And that's the graph for that. And then you could not include the 0 and include the 1. Okay? Now the last example I want to show is what if you want to say all reals greater than 1. And that's it. Just all reals greater than 1. Okay, let's go to the graph first. Here's 0. Here's 1. I'm not including 1. So open circle on 1. But I am including every real number greater than 1. That's over here. And there is no bookend on this other on the right because I said all reals greater than 1. So when there's no end in sight, I just put a 0. That's the graph of all reals greater than 1. Now, how do I do that in interval notation though? Okay, now you look at the interval. The left side is a 1. So I know that a 1 goes here on the left, comma. I know I'm not including 1, so that's why I have the parentheses. And on the right, there's no number where I stop. There's no border. It just keeps going on forever. So I can't put a number here, obviously. So when that happens, when there's no end in one direction, I just put the infinity sign. All real numbers greater than 1. That's what that says. Okay, so that's set builder. That's interval notation. Remember, interval notation is only used for real numbers. And graphing. See you next time.